Greetings, all you lean, mean motion machines. I have a feeling you're quite keen to learn how to do ferrofluids inside of Cinema 4D. And if you're not, it's almost too late for you, because the learning begins now. Boom! Here we are, Cinema 4D, and ready to rumble. There is a scene with a lonely petri dish, few lights, and not much else. And in the petri dish, that's where I want my ferrofluid to be. And the first step that we'll take is to create a simple disc. And that disc needs to cover the entire surface of the petri dish so it fits neatly into the center of it. And then I'm going to really turn up the segments for it, because we're going to displace this later. So I want it to be quite detailed. The disc segments as well, we've got quite a lot of. This looks to be enough for that, so I'm going to get started with my displacers. Click on the deformers and then select the displacer. Hold down Shift so it becomes a child of the disc. And in the shading tab, I'm going to create something called a layer shader. And in that one, you can just make loads of layers. For my first layer, I'm going to create a noise, one of my favorite shaders. In there, I'm going to use my not favorite noise actually, Voronoi 1, because that generates this kind of dented pattern. And then if I invert the colors of that, it's going to create something that looks bumpy, which is one step towards making the magnetic spikes, which I will want a little bit bigger. So I'm going to set the scale to 200%. If we're moving closer here, we can see how the bumps in the noise are displacing the disc and creating bumps on the surface. Let me just stretch out the attributes panel here, and then I will crush the highlights of this noise, which are now actually the black colors, and that will make these bumps a little bit spikier. And these slightly spikier bumps need to be a lot bigger. So in the object panel, I'm going to change the height from 100 up to 200. But then you can see this issue here. While it does make the spikes a lot spikier, it also makes the spikes go way through the petri dish. To remedy that, I'm going to change the type from intensity centered to just intensity. That means the black points are not being displaced at all and the whites are being displaced the full amount. While I'm in the area, I'm going to change the orientation from vertex normal to planar and make it only displace along the y-axis. Now then, time to make a fall off. I'll make that one spherical, make sure it fills the entire disc. And once it does that, I'm also going to make it a lot higher. Then I'll increase the fall off percentage, as well as create a rather sharp curve here to create the spikier center, just like I did in the Crystal City tutorial. And that just makes it look a bit more aesthetic. Now it doesn't move just yet, so let's start slapping on some motion to it. And this part is super tricky. I'm going to go back into the shader, go into the noise, and enter a value in the animation speed. That just makes the noise do itself. Let's make it do itself at a reasonable pace. That looks pretty okay. And with that step done, I'm going to name this large before creating a copy of it, which I shall call small, because now I'm going to make some smaller noise. So I'll start by making the height smaller, 15, sounds good. Then I'll go into the shader and completely delete this current noise and create a brand new noise and let that remain as a regular noise. But I will change the global scale down to about 20 and give it some contrast by increasing the low clip value to about 50%. Now that we turn off the big displacement, we can see that there's loads of little bumps in here. I want those to animate, so I'll add a value to animation speed. Just like that, we've created some motion. I will also tweak the fall off here to make it a little bit softer, so I'm going to change the curve first. That'll just make the displacement reach a bit further, and another thing I can do to make it reach further is to simply scale up the fall off a little bit. Giving it a playthrough now with the large displacer turned on, we can see that it's quite chaotic. Chaotic and spiky in the right ways. Now I'm going to get to play with another effector, namely the Jiggle effector. I do like me a good Jiggle effector because it can make rough motion look quite natural in a jiffy. As soon as we drop that in, we can see that we start to get some jiggle in there. With the Jiggle effector, there's always trial and error. This isn't my first tango, so I have some values that I know work okay for magnetic liquid look. I'll put structural quite low to around 10. Stiffness I'll leave quite high, usually around 70 to 75%. Drag is also something I want quite high, so I will put that to 25%. Then I'll actually go into the advanced options and turn iterations down to 2, which just slightly softens the entire motion. So, how do you feel about syncing this to some music? Let's copy the small displacement, put that ahead of the large displacement. I will rename it Waves because we're going to let this one create some waves to the beat for us. I want the height slightly smaller. And then I will go into the shader, and instead of a noise, I'm going to load a short video clip here that I made earlier. So that's a little motion graphic that I prepared earlier, which just synchronizes to the beat of a section of a track by Infected Mushroom. Then I have another version, which is slightly more hypnotic, which is just automatically generated inside of After Effects from the levels of the audio. And that's the one I want to use to displace this. So when I load that in and turn off these things, you can see when we play it through how there are some waves going across the surface. And when this is all rendered, that's going to sync quite nicely with that track. But we can still improve on this. I'm going to go into the large noise, go into the shader of that, and load in the other video, the one that syncs with the beats. So when I load that in, I'm going to select transfer mode for it to be multiply, and that means it's going to be completely dark, so it's not going to displace until the beat starts. And when it does, we get these massive ripples of spikes. And they shoot out in sync with the noise. Then I'll do the same for the smaller displacement as well. But there I want to use the volume-based one, because that one has a little bit more detail in it. So once I've set that to multiply, I'm actually going to turn the opacity slightly down, just to make sure there's always a little bit of noise in there. So now the Petri dish isn't quite as lonely anymore. It's filled with this crazy dancing liquid. If we give it a first render, perhaps somewhere midway through, we will see that it looks quite matte and dull, but it's also a little bit too spiky around the spikiest bits. So I'm going to create something called a smoothing deformer, and as you can see, it smooths things. At the moment, a bit too much, so I'm going to turn down the iterations and turn the stiffness up. I reckon somewhere around 75% should do the trick. It leaves the spikes a little bit spiky without being too spiky. And in this case, the smoothing deformer might have the added benefit of slightly preventing intersecting geometry. Maybe not completely, but probably to a certain extent. So, to make this smooth enough to render, I'm going to add it into a subdivision surface. I'm going to name it Ferro because it contains ferrofluid. And then drag it into a null object called Does Science. Now when it's rendered, I'd say it probably looks smooth enough. So now I'm going to create a material for it. As far as I know, ferrofluid is usually magnetic nanoparticles suspended in oil, so I want this quite dark and oily material, so I'm going to set the color really dark and then go into the reflection, and actually I'm not going to delete the default specular, I'm going to make it bigger but also slightly sharper. Then I'm going to add on a new layer, just a really simple Phong reflection, turn off the specular for it, and instead add a Fresnel. I'm going to choose a dielectric preset. And I wanted the material to be oily, so I'm going to pick some vegetable oil. It's a kind of oil. I don't think it really matters. So, I'll add the material to my ferrofluid, like so. And I'll turn up the subdivisions again and do a quick render. And I think this could look pretty okay after some contrast increase in post. Alright, stop. Let me give you a fair warning. We're about to delve into some Xpresso now, but don't worry, It's the simplest bit of Xpresso you'll ever learn, and it's incredibly useful. And there's no way using Xpresso is accidentally going to burn up your computer or anything like that. So I'll make this as approachable as possible. I'll call it Xpresso for people who are slightly uncomfortable at the thought of Xpresso. Take a breath. Ready? First off, we're going to create a happy little null object. I'm going to name it magnet position because that's going to represent where the magnet is affecting the fluid from. I'll add that to dust science. And then I will go into Cinema 4D tags and create our Xpresso tag. And this opens up the Xpresso window. First thing I'll do in this exciting and magical realm is drag the magnet position into the window. And this creates the magnet position null as a node. So now we have access to all kinds of data from that null object. And we want to plug that data into our displacers. So I'm going to grab both the large and the small displacer and drag those into the Xpresso window as well. And now we also have those as nodes. Right, so these little red friendly squares, they are outputs. If we click those, we get this list of available data to use as outputs. And on this null object, I want to use the position coordinates, not the global ones, just the local position. So select that one, and it pops up as one of our outputs. This little neato blue box, that is then inputs. I want to input the local position of the null object into the local position of our displacers. So we'll add those as inputs on the displacers and then simply drag across between the two to connect them. See, this isn't that terrifying, is it? If we just wanted to link up the position like this, we could have used a constraint tag. But with Xpresso, you can pretty much link any value on any object to any other value on any other object. That's pretty powerful stuff. So now if we move around the magnet position null, you can see how the displacers also move around with it. The power of Xpresso. Let's do some more, shall we? Let's go back into Xpresso, open up the window, and then from the position null, I want to grab the local Y position as well. And then I want to link that into the noise scale of the noise in our large displacer. So I go into the shader, and then I simply grab the noise, a little image here, and I drag that to the Xpresso window. An alternative way of adding inputs and outputs to your nodes is to find the data in the attributes manager and simply drag it to either the input or output field, like this, and then that becomes an input. Now, why do I want this? Well, I want to link the Y position of the magnet to the scale of the noise. Because the way ferrofluids act, when a magnet is close, the spikes are smaller and sharper, and as the magnet moves further away, the spikes become larger and softer. And if I scale up the noise like this, you can kind of see how it gives the same effect. So if I link the Y position of the magnet position null to the scale of the noise, when I move the magnet position down, I can then have the noise automatically scale up for me, and when I move it closer, I can have it automatically scale down. So if we gently slip back into Xpresso, I'm going to right-click and create a new node. I'm going to go into Xpresso, calculate, and in there you will find the range mapper. It already has an input and an output. To the input, I'm going to link the Y position, and the range mapper node has a lot of interesting stuff in it. It's got input lower, input upper, output lower, and output upper. Now it's remapping our Y position so that when it's 0, it gives an output of 0, and when the Y position is 1, it gives an output of 1. But let's turn the output range to percent because this is going to be our noise scale. So now, when the magnet position null is 0 on the y-axis, I want to have the output to be set to 200%. And if the y position of the magnet position null moves down 1 centimeter, I want the scale of the noise to go up by 1%. As long as I don't check any of these clamp tick boxes, if I move it further down, it's going to keep adding more and more percent. So if I move it down by 2 centimeters, the output is going to be 202%. If I move it down 3, it's going to be 203%. Now we just pop back into Xpresso and link the output of the range mapper into the scale of the noise. And then we can see that the scale of the noise gets this little symbol showing that it has an input from Xpresso. I'm going to lock this attributes panel and then select the magnet position and move it up and down, and you can see that as we move it down, the scale of the noise goes up. And if we do the same thing while we play it through, we can see how the displacement updates as well. Xpresso successo. Let me just unlock this panel again and then select the magnet and put it back to where it was. Now we can get started with animating this bad boy. The beat in the song seems to start around frame 15 to 20, and when it starts I want the noise to be quite big. I'm going to start by setting it to minus 150. And I think that makes it big enough. And then I want to set a keyframe for that around frame 15. Then over time, I want the noise to scale up. So by about frame 22, I'm going to move the magnet position almost all the way up. Actually, let's have that happen a bit later, about frame 40 might be better. And then I'm going to set it to minus 25. Now when we play it through, the magnet moves up and the ferrofluid spikes scale down. And I do believe our animation is just about ready for render now. Now keep in mind you don't need to apply this to a disk, you can really use any model or object with enough subdivisions to give enough detail. So there you go, if you layer some deformers and some jiggle you can get some really cool effects, and I hope you do. I also hope you found this useful, I hope you found it fun, I hope all your dreams come true, I hope you find gold tomorrow, and I hope I'll see you next time, and until then, I hope you stay in motion.